Okay, so a big part of factoring, by the way, factoring is something you're going to hear about from here on out in math. Now that we're learning about it, this does not go away. A big part of factoring is something called the greatest common factor. So example one, what is the greatest common factor, or GCF, of the terms 12x to the fifth plus 8x to the fourth minus 6x to the third? So I'm going to really break this down, and then as we continue through the lesson, we'll just see how we get our GCF a little bit less broken down, but I want to make sure we understand what we're doing the first time we see this. So greatest common factor is going to be, like we said, the largest factor that all the terms share. So let's just separate out our terms. We have a 2x to the fifth. We have an 8x to the fourth. I'm going to ignore that negative for a second. We'll come back to that in our next example. And a 6x to the third. Let's start by looking at the coefficients, the 12, the 8, and the 6. If we go through our prime factorization of 12, that is 2 times 6. 2 is prime, so we're done with that. Let's break the 6 down into 2 times 3. Those are both prime, so we have a 2 times a 2 times a 3. We're going to do the same thing with the 8. Start with 2 fits in 4 times. The 2 is done. Let's break down the 4. That's a 2 times a 2. Those are all prime, so 8 can be rewritten as 2 times 2 times 2. 6 is 2 times 3. Those are both prime, so we have 2 times 3. So what we're looking for is if they have any common factors. Well, the 12 has a 2. The 8 has a 2, the 6 has a 2, so that's a common factor. They all have a common factor of 2. Now we want to see if they have any more than that, because we are looking for the greatest. The 12 has another 2, the 8 has another 2, but the 6 does not have a second factor of 2, so we cannot circle these 2's because it's something that all three terms have to have in common. Let's see, the 12 has a 3, the 8 does not have a factor of 3. So that's all we have for our coefficients. They had a 2 in common. 2 was the common factor, and it was the greatest common factor that they had. Now let's take a look at the x's. It's 12x to the fifth power, so that's x times x times x times x times x. 8x to the fourth, so we have 4 of them, x times x times x times x. And then it was 6x to the third power, x times x times x. So let's see if they have anything in common. Well, they have x's in common. That's kind of clear. So let's see. Here's an x in common with an x in common with an x. Great. Do they all have another x in common? Yep, we have enough x's. Now they both have an x and an x in common. Is that it? Oh, I think we can get a third, third, third. And if you notice, that's all that this term has. So that's the most that they will have in common. There's no more x's here to have in common with the extra x's of the other terms. So we would say that they have an x times x times x, or x to the third power in common. So once we have identified that, our greatest common factor is the 2 and the x to the third power. And we just put those together as one greatest common factor. All right, so now that we kind of see how that works, this will start to get a little bit faster. First, we identify the greatest common factor of the leading coefficient, or the coefficients, excuse me. So part A, we have a 15 and an 18. So why don't we do that prime factorization again. 15 is 3 times 5. Those are both prime, so that's a 3 times 5. 18 is 2 times 9. 9 breaks down into 3 times 3. So we have a 2 times 3 times 3. And I'm going to write that a little bit lower. That one was 3 times 5. So do they have anything in common? Let's see. They both have a 3, so they have a 3 in common. We've got a 5 here, but no 5s here. We have a 2 here, but we don't have a 2 here. So that was the only factor they had in common for the coefficients. Now we have to look at the x's. That 15 has an x squared, so we have an x times an x. The 18 doesn't have any x's with it. So do the two terms have any x's in common? They don't. So that means the only common factor, and it is the greatest common factor because there was not one bigger than that, is that 3. All right, so now let's take a look at some strategies we can use for finding the greatest common factor. We have our 1, 2, 3 terms, so let's go ahead and write those down. We have a negative 18, a 6, and a 24. To find the greatest common factor, what you can do is look at your 3 numbers and focus on the smallest number. 6 is a factor of itself because 1 times 6 is 6. Does 6 fit into 18? It does 3 times. Does 6 fit into 24? It does. So that means that we are identifying part of our greatest common factor. It's going to have that 6 in it. So ideally, you're trying to find what's the biggest number that fits into all of these coefficients. That's essentially what we're doing. And if you start with the smallest number, 6, that's the biggest factor that fits into this term, 6. So see if that fits into your other ones. All right, let's look at our y's. We have a y to the 4th, a y cubed, and a y squared. So whatever, kind of like we looked at our smallest coefficient of 6, let's look at the smallest y's. Here we have a y squared, that's a y times y. This one has a y times y plus an extra. This has a y times y plus a couple extra, but this is the most that they all have in common is that y squared. So we're going to put a y squared into our GCF. Now, one note we need to make, if your leading term, this is what we call the leading term, the term with the highest exponent. If your leading term is negative, then you want to make your GCF negative also. So the GCF is going to be negative 6y squared. That's something that if you get in the habit of now, moving forward with our factoring lessons for the rest of the chapter, you're going to want that GCF to be negative if you have a negative leading term.